Hello students, in this video we will learn about relationship between trigonometric ratios such that it is related to the number 1, and we'll see how that is. For first, when we begin, we have to start with the six-sided hexagon, a regular hexagon which is a six-sided closed figure. Once again we will draw their diagonals this way, okay, and we'll mark over here sine, cos, tan, cot, cosec and sec. Fine, this is our regular hexagon we have been drawing now in the past videos as well, so we'll continue, and now we'll put something addition over here, that is we'll put the number 1 over here in between. This one is significant. So let us begin with our first formulas. Our first formulas is when we multiply sine theta into cos theta, we get the number 1. So sine theta into cosec theta will give us 1. Sine theta into cosec theta should give us 1. Let us see how. Remember original values, that is of sine theta, cos theta, tan theta, cot theta, then your sec theta and your cosec theta. If we don't remember, we should recall Pandit Badri Prasad Har Har Bole. Pandit Badri Prasad Har Har Bole will help us get these values. So this is our sine P upon H going downwards, right? So we'll write over here P upon H. What is cos? B upon H. What is tan? P upon B. Now what is cot? Cot is going reverse way from bottom to top, which is B upon P. Sec is H upon B. Right over here cot, and this is sec, and this will be then cosec, H upon P. Now let's use these values over here to find out whether really sine theta into cos theta is equal to 1. Then only the way we have found out sine theta into cosec theta into equal to 1 will apply for the rest. So let us check the left hand side. The left hand side says sine theta into cosec theta. Now what is sine theta as per Pandit Badri Prasad? P upon H. What is cosec theta? H upon P. P and P cancels and H and H cancels, and we are left with 1, which is equal to our right hand side. That means sine theta into cosec theta should give us 1. Similarly, if sine theta and cosec theta, these are opposites of each other, and when they are multiplied with each other they give us 1. Easy to find out on this particular figure. Similarly, if cos theta is multiplied with sec theta, it will give us 1. So cos theta into sec theta equal to 1. Remember, these are opposites of each other. Have a look. Sine theta is P upon H and cosec theta is H upon P. Similarly, cos theta is B upon H and sec theta is H upon B. Coming to our tan theta. So tan theta multiplied into cot theta will give us 1, right? So have a look, we have got opposite, we've got 3 new formulas now. Sine theta into cosec theta gives us 1, tan theta into cot theta gives us 1, and cos theta into sec theta gives us 1. Now alternatively we can also write sine theta equal to 1 upon cosec theta. So these are 3 formulas more. Sin theta can be written as equal to 1 upon cosec theta. How? If we keep sin theta over here, and cosec theta can be taken down. So 1 upon cosec theta. Alternatively, we can write, or rather we'll continue that way. So cos theta can be said as 1 upon sec theta, and tan theta can be written as 1 upon cot theta. How many more we have got now? 3 more. This way for sine, cos and tan. What about cosec, sec and cot? Yes, we can definitely write similar things for them. For example, cosec theta. So here we keep cosec theta on the left hand side and we take sine theta on the, because these are multiplied, when they go on the other side they get divided, okay, and they go into the denominator. So cosec theta can be written as 1 upon sine theta. Then you have your sec theta, which can be written as 1 upon cos theta. And finally we have our cot theta, which can be written as 1 upon tan theta. So how many we have got now? 3 more. So doing this, we have got 3 plus 3 plus 3, 9 formulas we have got. Remember, we don't have to by heart any of these formulas. We just need to remember Pandit Badri Prasad Har Har Bole, and we need to remember this figure and how to get their relationships with each other. Here we have put 1 in between, and we have been able to derive 9 formulas from this simple method. Now, moving further, these were 9 formulas. Let us explore more formulas. In the next set, what we'll do is we'll only focus on these triangles. Okay, just on these triangles, and we'll look at the relationship in this fashion, clockwise. Okay, have a look. Follow the arrow. However, look at the arrow this way. So it is clockwise. So we begin with, and it will be their squares we will be dealing with. Sine square theta plus cos square theta equal to 1. Sine square theta plus cos square theta equal to 1. Because it is clockwise, the positive sign will always remain the same for all of them. So we had started with sine theta, cos theta, and come to 1 theta. 1. Sine square theta plus cos square theta equal to 1. Similarly, in this case, we begin with 1. See how it's starting, the tail of the arrow, 1 plus cot square theta. So 1 plus cot square theta equal to 1 plus cot square theta equal to cosec square theta. Basically, these are all squares. We don't write 1 square, or we don't write 1 square is 1. So we just end up writing 1. Okay, we'll leave it at 1 because we have 1 over here. So 1 plus cot square theta gives us cosec square theta. Similarly, in this case, look at where the tail of that arrow is, 10, right? So it is tan square theta plus it goes to 1, and we get sec square theta. Have a look, sine square theta, cos square theta, and 1. So if I put it this way, it is sine over here, cos over here, and 1 over here. Okay. Similarly, if you look at the next one, it is, if we draw an arrow this way, then it is 1 over here, then cot over here, and then we have our cosec over here. Similarly, for the third one, if we draw an arrow this way, we have our tan over here, 1 in between, and sec over here. All we do is get their squares added up. So sine square theta plus cos square theta gives us 1. 1 plus cot square theta gives us cosec square theta. And tan square theta plus 1 gives us sec square theta. This gives us 3 more formulas. How many more? 3 more formulas. See, we can easily find out whether sine square theta plus cos square theta is equal to 1. Let us just find out. Let's use this, sine square theta, cos square theta. So we'll take left hand side equal to sine square theta plus cos square theta. Let us see if it comes equal to 1. What is sine theta? P upon h, which means the square of that will be P upon h whole square equal to cos square theta. Sorry, this is addition sign in between, B upon h whole square. Now we'll get P square upon h square, and this will be nothing but B square upon h square, and we add P square plus B square whole thing upon h square. Now this is the addition. Now if you have a look at our triangle, okay, and at any point of time you will have your h over here, you will have your B over here, and you will have your P over here. P stands for the perpendicular, B stands for the base, and H stands for the hypotenuse. Since this is a right angle triangle, we can apply the Pythagoras theorem. We can apply the Pythagoras theorem. And what does the Pythagoras theorem says? It says that the square of the hypotenuse is equal to the sum of the squares of the sides, other two sides, which is the perpendicular, square of the perpendicular plus the square of the base, which means B plus P plus B square is equal to h square. So h square upon h square is what? 1, and that proves that sine square theta plus cos square theta is equal to 1, and that's how we get this. So similarly, if we go to check 1 plus cot square theta, it will give us cosec square theta. Let us check that out. Okay, let us take the left hand side, which says 1 plus cot square theta, and let's see if it comes to cosec square theta. So 1 we write, and we'll look at what is cot. Cot theta is B upon P, so B upon P whole square. Now this will be 1 plus B square upon P square. If we get the LCM, it will be P square plus B square upon P square. Now have a look, what is P square plus B square? It is h square. So h square upon P square, which we can write as h upon P the whole square. What is h upon P as per Pandit Badri Prasad? It is cosec theta, which means this is cosec theta whole square. Have a look, 1 plus cot square theta is equal to cosec. So when we bring it inside, it will be cosec square theta, which is our right hand side. So 1 plus cot square theta equal to cosec square theta, and this we got without doing this entire problem. We got it just by looking at the figure and establishing a relationship. 1 plus cot square theta will give us cosec square theta. I leave the last part up to you to find out if we can get the last one proved, that is tan square theta plus 1 equal to sec square theta. You can do it, try it on your own and find out whether left hand side is equal to right hand side, and I'm sure you will get left hand side equal to right hand side, that is tan square theta plus 1 equal to sec square theta. Let's move to the next set of formulas. For the next set of formulas, I have redrawn this figure, I have cleared this up, but once again we will need that one in between. Okay, we'll need that one in between. Once again we'll need these three triangles. Okay, this one, so I'll mark this way, and sorry, not this one, we'll need this one, alternate triangles. Okay, and this one. Okay, so these three triangles, and this is our one in between, 1, 2 and 3, the same triangles that we used to get the previous three formulas. Now however, in the previous method we went clockwise, so in this particular for this particular set of formulas we'll go anti-clockwise in for all these three formulas. We'll get three more formulas by going anti-clockwise. And remember, when we went clockwise, there was an addition sign. Over here, since we go anti-clockwise, anti means against, negative, so we will find a negative sign in between. So it will be starting with 1. From the, look where the tail is, from the tail it begins and goes to the head of the arrow. So it will be 1 minus cos square theta, which will give us sin square theta. Look at where the arrow, see the arrow is this way, we have 1 over here, we have cos in between, and we have sin over here. So 1 minus cos square theta gives us sin square theta. Here it is going anti-clockwise, and because it is going anti-clockwise, we have a negative sign over here. So this time it begins with 1. Remember last time it was clockwise, starting with sin. Sin square theta plus cos square theta gave us 1. Now we begin with 1, and since we go anti-clockwise, it is negative. 1 minus cos square theta gives us sin square theta. Similarly over here, what do we have over here? In this case, we begin with cosec square theta. So cosec square theta minus cot square theta will give us 1. Once again, have a look at the arrow. It begins with cosec, then it goes to cot, and finally it ends with 1. Now for the third one, have a look. It begins with sec. So sec square theta minus 1 will give us tan square theta. If I redraw the diagram arrow, then it begins with sec, it goes to 1 in between, and finally the arrow head ends up at 10. So we have got 3 more formulas. 1 minus cos square theta gives us sin square theta, cosec square theta minus cot square theta gives us 1, and sec square theta minus 1 gives us tan square theta. Now this is almost the same as what we learned previously. The previous one was what? Sin square theta plus cos square theta equal to 1. In this case, nothing great is happening except for this cos square theta going on the other side, that is going to the right hand side. So once it crosses over that equal to sign, the positive sign becomes negative, and we get sin square theta equal to 1 minus cos square theta, same as this. So in the previous one we got this, just by changing we have got this. Got it? Now similarly we can say the same thing in case of cosec square theta minus cot square theta. So previously we had got 1 plus cot square theta equal to cosec square theta. Now this is cosec square. So I'm not going to sit to prove once again, because it's the same thing where the positive sign has become negative just by going or crossing over to the other side of the equal to sign. Okay, so we have 3 more formulas just by changing over the signs, and this can be very helpful in solving various problems. So with this we have completed all the formulas that we had to learn with respect to the trigonometric ratios. Okay, I hope you have been able to understand and grasp all the methods in which we derived all these formulas. Make sure you do not look to memorize it or by heart it. Just remember Pandit Badri Prasad Har Har Bole and this figure, and with the help of this figure and this mantra you will be able to derive all these formulas and use them to solve various problems in trigonometry. So if you have liked this video, please click the like button, share it with your friends and classmates. Please subscribe to the channel and click on the bell icon to receive notifications whenever a new video is posted. Thank you for watching. See you in the next video.